Welcome back, guys. Welcome to the second question from the sample test exam. Today we are going to solve question number 1 in problem number 2. Given a graph below, this is the graph. It's a directed graph, as you can see. So we have to represent it in a linked list representation. Remember, we have studied in the lectures 2 representations, the matrix and the linked list. Store the vertices in alphabetic order, then apply the breadth first search to find if there is a path from A to D. So we want to go from here to here using the breadth first search. Okay, so let's go directly to the solution. Here is a graph, and here I have written the vertices. We have, as you can see, A, B, C, D, E, F, G. A is connected to what? A actually is connected to, as you can see from the graph, A is connected to B in alphabetic order, and also A is connected to E. This is the linked list representation. A is connected to E also. The same will go for B. B is connected to what? B is connected only to F. So here we put just F. C is connected to D, and C is connected to B. So we'll begin with what? And A. So we'll begin with A because it's alphabetic order. Then we'll begin with the second one is B, and the third one is D. And you continue like this, and you will get something like this. So this is the final representation of the graph using the linked list representation. This is F is connected to C and to E. This is E, okay? So this is E. E is connected to B. D is connected to A and F. C is connected to A and B and C, and that's it, okay? As you can see, it's an easy. You can represent it using matrix and using what? Using a linked list. Now let's go back to the second one. We have to use the breadth first search. To find a path from A to D. Let's go back and let's try to implement the algorithm. So let's begin from node A. So A and the Q contains A. Remember a Q, here the front and here the end, okay? Then from A, we are going to remove A, the Q will be empty, and then replace it by its children. A has two children, B and E, okay? So first of all, we are going to replace B, so the Q will contains what? Will contains B, okay? And then insert E, so will contains B and E. Remember, B is the front and E is the end, okay? Then after that, I'm dealing now with B. I have to remove B. Then the Q will contains what? Will contains E. Then replace B by its children. B, it has only one child, sorry, which is F. So here we replace F, and here we will have what? We'll have E and then F. The same technique. Remove E now and replace by its children. E has B and has C. But we have already visited B, so we don't put B again. So we have only insert what? Insert C. But before that, remember, I have to remove E. So then nothing here will be inserted, and I'm gonna remove E, and I will end up with F. And then I have to insert what? C, and here I will have F and C. Now I'm dealing with F. Remember, F, it has two children. It has C and it has E. But we have already visited C and we have already visited E. So what I do here, I just remove F, okay? And I will end up here with C, okay? Also the same idea. C, it has how many children? It has A, B, and D. But I have already visited B and I have already visited A and B. I have already visited them, so I deal with what? With D. But before that, what should I do? I have to remove C. So here I will have empty Q again, and insert what? Insert D. I will have here what? I will have here D. And this is the end of the algorithm. I have begun with A and I have ended up with what? With D. Okay? So using breadth first search, I can go from A to D. We can represent this as a tree. If you remember, A, it has two children, B and E. E, it has also B, it has one child, which is F. E, it has two children, B and D. I don't care about B because I have already visited B, so I go from E to C and so on. Okay? So that's it for question number 1 in problem number 2. Please, if you can, try to do, instead of breadth first search, try to do the depth first search and check your results. Okay, see you. Bye.